7.1 is probability distribution. So far we've focused on individual probabilities, so probability of one event. And now we're going to look at probabilities distributed across all possible outcomes of an experiment. Okay, so this is all possible outcomes. So for example, actually, let's go through definitions first. A random variable. So at the beginning of these questions, we must determine what the random variable is and then define it. So the random variable x, so x describes in general the desired outcome and has a single value, which is like little x, denoted for each outcome of an experiment. So for example, the random variable x is the number rolled with a die. And notice that this is capital X. Okay, so x can be 1, x can be 2, 3, 4, 5, or 6. So this random variable x can be any one of these outcomes. So basically what we're doing is we're listing every single different outcome. Okay, and then let's focus on discrete versus continuous. So discrete variables have values that are separate from each other. Okay, so they can only take on certain values. For example, points scored in a basketball game. You can't score 2.5 points. You can't score negative 10 points. So these are discrete variables. This example will only have positive integer values. It'll have 0, 1, 2, 3, so on. And continuous variables have an infinite number of possible values. They can take on any number, okay? So we're talking about height. So you don't go to sleep tonight and you're 5 feet tall, and you wake up tomorrow, you're 5 feet 2, all right? So height doesn't jump like that. Height is completely continuous. Time, okay? Time's not choppy, time's fluent, right? It's continuous. Blood pressure. So all of these things we actually measure in like discrete numbers. Like we measure and we round to maybe 2 decimals or round to the nearest inch, right? If we're measuring maybe like height. But these things are actual like measurements, okay? So we can't actually measure them exactly, okay? Since they are continuous. Okay, so let's do example 1. So let's classify each of the following random variables as discrete or continuous. So the number of phone calls Sally's mom makes at Christmas. Phone calls. So phone calls, you either make a phone call or you don't, and you can't make half a phone call. So this one's going to be discrete. Okay? Okay, the length of time Sally's mom spends on the phone. So when we're talking about time, time is a measurement. Okay, we can round to the nearest second, but it's not going to be actually exact. This is going to be continuous. Okay, a company's annual sales. So we know that money is measured in dollars. Okay, so it's always going to have two place values after the decimal. So this is going to be discrete. So even though this involves like that fraction or those decimals, it's still discrete. Okay, number of cars sold by Honda. Again, this is going to be discrete. You can't sell half a car. You can't sell a quarter of a car. Okay, it's going to be 0, 1, 2, 3, 4, and so on. And the distance from your house to the school. So distance, again, that's going to be continuous because it's a measurement. Even though we continuous. Even though we can say, 8 meters is going to be 8 and a bit, and this many centimeters it's going to be always be between those measurements. So it's just kind of, it's a good approximation, but it's still going to be an approximation. It can take on any number.